This video demonstrates the capabilities of EVA, an electronic vaccination analysis system that's designed for the development, testing, and deployment of vaccination knowledge. Its particular demo is based on information made available by the Indian Academy of Pediatrics, plus some other information put in for illustration purposes only. It's for demonstration only. In a previous video, we showed how EVA could be used for just a single vaccine with a single dose to show the simplest case and introduce the various capabilities of EVA for representing knowledge. In this case, we have added all of the information on a number of different vaccines, which is part of the basic schedule specified by the IAP. Over here on the left, we can see the vaccines that have been added to the system: DDP, measles, we have a combination vaccine, MMR, the two polios, etc. Another capability in EVA is the ability to have type families, and it's used now for specifying which vaccines are live virus vaccines. This is useful because the live virus vaccines need to be separated from each other by a minimum interval. EVA also handles combination vaccines, so it knows how to deal with both the combination vaccine and the components each as necessary. Here's how we define a taxonomy of these vaccines. In this case, we have MMR, which contains measles, mumps, and rubella. And over here we have synonyms. DTP is composed of, has different ways it could be spelled. It could be either DTPA or DTPW, or in boasters. When any of those are specified, then the system will understand that that's a DTP. On the bottom, we can see all of the various tabs, worksheets here in Excel for the different vaccines that we've added. And let's look at a few of those as they illustrate some of the different capabilities. OPV has a 6-dose schedule, begins with dose 0, and we can see that in the table. And the rules we have are relatively simple. It just applies the table in general. The exception rule is that when we have more than 6 OPVs given, the status is complete. Now, ordinarily, we would only need one rule to say use the schedule to decide what's next and to analyze what's been happened, and those rules look like these, as we saw when we looked at BCG earlier. But in this case, we're going to have two different rules, and they're only going to differ in the comment. This is because OPV is recommended to be used with IPV for the middle 4 doses, not the 2 N doses. So we're going to have two rules here, one for the 2 N cases, in which case our comment is going to be that we're on the standard OPV schedule, or the 4 middle cases, in which case we're going to make the comment that we recommend they give IPV as well if available. The IPV rules don't have a table, but we can see that the schedule for IPV uses the OPV schedule. So the various vaccines can communicate with each other as necessary, as we can see in this example. So if the dose is between 1 and 4, if that's the dose number, then we will use the OPV schedule. The recommendations for IPV also are based on the OPV schedule, and the comment is always to use IPV in conjunction with OPV when available, if it's one of those 4 middle cases. MMR is a combination vaccine. It has a simple table. It has two doses in it. And we can see that the rule for MMR is that when you have more than 2, we're done. As far as scheduling, though, when we apply it, MMR is a live virus. So we notice that the scheduling rule is a little more complex than the ones without a live virus, because not only do we need to consider the separation from the previous one, the use of the schedule's recommendations, but we also need to consider the separation from any previous live virus. So we have a rule there that looks for what was the last dose of a live virus, and that the minimum separation is 4 weeks, greater than that. And when we now compute what is going to be the minimum date for this, we need to look at the maximum of the minimum date based on interval, the minimum date that might be possible given the live virus separation, and the minimum age specified. So all three are going to go into computing when is the minimum date for this vaccine. Measles is an interesting case here because it's part of MMR, but it's also asked to be given separately before the main MMR sequence starts. So the way we implemented that knowledge was to create a single measles dose for that early dose, a single simple schedule for that. And in the rules, say which schedule do we want to use. If we're talking about dose number 1, then we want to use our simple one-dose schedule. If we're talking about a dose greater than number 1, then we want to use the MMR schedule. So which schedule we use in measles is going to depend on which dose we are. The full count of measles, if we have more than 3, then that's a complete measles schedule. But if the valid count of measles is greater than or equal to 1, we want to make the status not applicable, because in this case we're recommending that they use MMR after that first dose. So we're saying don't use measles, use MMR after you've already had that initial one. And for the scheduling of measles, notice that as with MMR, we need to make sure that we have the live virus separation, that if some other live virus had been given, we want to make sure that we have a 4-week separation from it. Mumps and rubella, we're also going to include for historical analysis purposes. We're not going to do planning with it, but we are going to be able to look at it and see how many mumps you've had and how many rubella you had. But they're going to follow the MMR schedule exactly. So our rules for mumps basically say use the MMR schedule and use the MMR status for mumps. And we'll do the same for rubella. Typhoid is an interesting case in that it doesn't have a schedule, a specific schedule. It has just a single first dose recommended at 2 years of age, but after that it repeats every 3 or 4 years based on when the last one was. So instead of trying to put that in a table, we're going to write the rules for computing that directly in the rules instead. We're going to have 2 different sets of the schedule, one used for historical analysis and one used for planning purposes. For planning purposes, we want to compute the last dose of typhoid and then specify when the next ones are going to be due and recommended. But for historical analysis, we need to look at the dose we're looking at, find the previous dose and before that, and then compute when it should have been based on when that previous dose was, and then we can analyze it. For planning purposes, we still use the schedule just as if it was a tabular schedule. This rule doesn't care whether or not we're actually computing it as we do or get the table. And one last rule to look at is HPV, which is unique among the vaccines in that it is gender specific. So in our exceptions rules we have here that if the gender is not female, the status is not applicable. And so that's something interesting about HPV. One more note on the vaccines, the main definitions is up here. We say how they're going to be used. So notice for IPV, we're not going to do any history. We're just going to do planning because IPV is optional. We don't really care how they've been given in the past. As for mumps and rubella, because they're part of MMR, we do want to see the history as to how they were given, but we don't want to do planning because we're going to be using MMR for the planning purposes. We can now go through the test cases to see how this new knowledge plays out as we test it. Here's our first case of a newborn male that has received no vaccinations. And again, reviewing the green are stored in the database for regression analysis. The yellow results are the ones that are current based on the current data, and hopefully they're the same as what the green ones are, which we didn't previously. There is no history for this case because he hasn't received any vaccinations. And here's his forecast and planning. 3 of the vaccines are due, and those are the birth vaccines, BCG, Hep B, and OPV. And the other vaccines are all current, and current means that nothing is necessary right now. He's up to date on whatever schedule that is, which is none for the newborn baby. But we can see that HPV has a status of not applicable because this is a male and it's for females only. Let's look at a female now who's had about 7 weeks old, who's received some of the 6-week vaccines, not all of them, but has received some of them. We can look at the history here and see that these had the 2 OPVs as required, and the hepatitis Bs and the BCGs are all fine. If we look at the forecast and the plan, however, we notice that DTP, Hib, and HPV because she's female, are all due. That they should have been given. They should be given at 1 month and 11 days, and she hadn't gotten those, and so she does need those. The other vaccines are all current. Another capability of EVA is to set up test cases to look at just a particular vaccine, just to see how the rules are working. So in this case, we want to see how the measles and MMR interaction is working. So we give it a list that we only want to study MMR here, and we're not interested in the rest of the vaccinations. Let's just see how this case plays out for that. And we've given this kid a measles and an MMR. And we can look down here at the history and notice that mumps and rubella are reported as well, that he's had 1 each of mumps and rubella, which was part of that MMR vaccination, and he's had 2 measles. One was the original solo measles plus the MMR, and he's had 1 MMR. In our forecast down here, we're not forecasting mumps and rubella, but we are measles. We're saying it's not applicable because you should use MMR, and the MMR we're saying is due for the 2nd dose. We also generated a separate test case for typhoid to just see how the scheduling is working for typhoid, and here we see 2 typhoids. The second one was given at 6 years, which is more than 4 years from the second one, and you'll notice the comment on the history is that it's after the recommended age. We're a little late with that second typhoid, and our third one is due at 9 years of age here. I think that gives an overview of the various capabilities. There are more features in here that have been illustrated, but this kind of shows you what can be done with EVA. It can represent a wide variety of complexity and different kinds of vaccination knowledge. It can also be created extremely rapidly. This demonstration was created in about 2 days' time.